Alrighty, everybody. Welcome back to another exercise walkthrough. Today we're going to be working through exercise 5 on vector analysis. Now, in this exercise, we're going to be analyzing global anti-shipping incidents, aka, piracy, specifically within exclusive economic zones, or EEZ. If you don't know what EEZ is, it's basically this zone off the coast of any coastal nation or state where they have jurisdiction to do what they please, and it extends about 200 miles off the coast. And then after that, you're kind of in open waters instead of being within the jurisdiction of whatever state has, that zone is theirs. So to get started, of course, we're going to connect our data folder and we're going to add our data to our map, which I've already done. And a good first step for any exercise, but specifically this one, is to just take a look at the kind of data you've got. So I'm going to start turning on layers one by one just to see what I'm working with. Here's our anti-shipping activity messages. So these are messages from ships and other outposts that would log any acts of piracy going on. We see it's a worldwide shapefile. We also have our world EEZs, our economic exclusion zones, or exclusive economic zones, sorry. Extending again that 200 miles from shore of every marine country that edges with the ocean. We have our Caribbean islands. I'm going to open this up so I can kind of see the symbology of each of these. I can tell it's a polygon from this symbology here. I'm going to zoom to layer. See, there's just a polygon going over the Caribbean islands here. And then our country shapefile appears to be polygons going over all of the countries, including the Caribbean islands. It's just hidden under the Caribbean islands specific shapefile. So now that we can kind of see what all of our data is doing, now's a good chance to inspect everything. You can go through attribute tables. So I can see here that this looks like some kind of date and then ID here. We have date of OCC, so possibly date of occasion, the date that the anti-shipping message went out. Subreg, some kind of regulation or register number. Aggressors, you see we have robbers, pirates, suspicious approach. Those seem to be our main 3 categories of aggressor. The victim, it's tankers, vessel, cargo vessel, fishing vessel, container vessel, bulk carrier, lots of different vessels here. We have a few different descriptions going over the incident. So it looks like there's a lot of data contained within each of these points. Another place you can search is in your properties. So your source tab is going to be super useful in telling you, in confirming that this is a polygon shaped file. Can tell you your extent. So this is the extent of the file. So, if you had a file covering every single tree that existed in Florida, the extent would be different than every tree in, Virginia. And this extent would tell you where that was located based on some kind of origin. Typically, it is the equator. So here we can see that our EEZ is in degrees. So which makes sense because our numbers are so small. So having, if this were meters, that'd be a very small extent, which we know is not correct because our EEZ is a worldwide shapefile. You can also see our spatial reference to see our coordinate system, angular unit, which is degree, the datum. We can also see our resolution, which is not super helpful in this particular case. Because it's by degree instead of by meter, like a raster resolution would be helpful. So yeah, go ahead and take your time to explore all 4 of these shapefiles that you've got and use what you find to answer your first 4 questions for this assignment, or use your first 4 questions to direct where you're searching. It depends on which direction you want to take it. You're answering what the full coordinate system is of the exclusive economic zone polygon dataset. Question 2 is whether the world exclusive economic zone dataset is projected or geographic, which we kind of spoiled over here already. Whether our EEZ data is vector or raster, and what our source for that data is. Where did it come from? Now we're going to move on here and come back to our ASAM data. We're going to look at the properties. You may have noticed something a little bit strange, is that hold on. Okay, I'm back. So in your instructions, it talks about how the coordinate system is unknown for this file, which it isn't. We have it right here that it's the WGS 1984 geographic coordinate system, and our unit is degrees. So in this particular case, there just seems to be a discrepancy between the data you've been given and the instructions. So don't worry about that too much. But we are still going to go through the steps of how to define a coordinate system, because that's a really important skill to know going forward with future analysis. So I'm going to close everything up to kind of clear up my file here. So the first thing to do when you're taking a data set without a coordinate system and giving it a coordinate system is that you need to know which coordinate system to give it. And you can't just guess. You've got to know which coordinate system the data is meant for. So part of that you can kind of guess. If you don't know, and there's nowhere to check, you can kind of guess by coming here to your extent and just pretend that there's no units here. We can see that our extent values are quite small. Again, if you had an extent that went from 67 meters to 44 or to negative 44 meters versus, if this were meters, that would be a very small area just around wherever its origin is. So it's much more likely for this to be degrees, which means if it's degrees, then it would be a geographic coordinate system. That's the only time you'll see your units as degrees. If it's any kind of standard distance measurement, meters, feet, miles, kilometers, that's going to be your projected system. So we already know now that it's supposed to be a geographic coordinate system. If we didn't know this, we have a few to choose from. The most common are the NAD 83 that we've worked with, which is specifically North America, and the World Geodetic Survey, WGS 84. It would make, if we were figuring this out from scratch, the world system would make more sense because our ASAM file covers an extent of the whole world. And thankfully for us, the instructions tell us that the website that we got this data from, our source for this data, informs us on which coordinate system it's supposed to be, which is in fact our WGS84, which again, for us is not a surprise because it already has the system. But let's say it didn't, and we needed to give it a coordinate system. We're going to come here to Tools, to our geoprocessing panel, and we're going to use the Define Projection tool in our data management tool set. And we're going to input our feature class. We're going to give it the coordinate system that we want. In the case where we didn't know this and our data set didn't have a coordinate system, we would want to select the correct one from here. So we would go to our geographic, we would find our world and look for WGS 1984. And then we would run it. I'm not going to run it because I don't want it to mess anything up in here because this data set already has a coordinate system. As you can see, this little warning symbol that has popped up is telling me that there's already a defined projection for this. So I'm just going to leave it. But if you do need to use this tool, that's how you would use it. Moving on to our first task, we are going to determine which EEZ has the highest density of incidents. Typically, when you're doing analysis, determining the area with the highest density of events is more effective than the highest number of events. It's not always this case, but oftentimes it will be because since area can differ, between, say, India versus Canada. Canada is much larger than India. So if there were, say, 10 events of some kind in Canada, it would look like there were more events. It was more common to see that in Canada versus, say, 6 events in India. When you take into account the area, you may find that there is much less discrepancy between the two, or that the density of events happening in India is far greater than the density in Canada. Particular example is that though India is much smaller than Canada, it has a much higher population density. There's a lot more people living here than in Canada. So we're going to determine which EEZ has the highest density of anti-shipping events by performing a spatial join, which is going to count how many incidents, and then we're going to normalize the data to get all in kind of a comparable plane. We're going to normalize it to determine the true density instead of just the count. So the first thing we're going to do is we're going to do a spatial join. Now, this spatial join is going to be useful because we're going to be taking the events happening in our ASAM dataset and we're going to be joining it to the spaces defined by our EEZ dataset, since we can't have polygons and points in the same dataset. So we are going to come up here. So we're going to click on this data. We can come here to joins and relates and do add spatial join. We're going to select our target feature, which in this case is our EEZ, which is why we went through there. Our join feature, and if you ever have a question about what data should go in what box, this little information bubble is going to be super helpful because it's going to tell you the target features is asking for the attributes from the target features, and the attributes from the join features will be joined together in the target features layer. And our join features. Okay, well, this is a kind of poor example. This doesn't explain very much about what data you should focus on, but for right now, know that your target feature is going to be the area you are targeting, and you are joining the events that you're looking for. So we're going to join our ASAM data. I'm going to keep all of our target features. We want our... Okay, so our match option is going to be intersect. So we want the spatial join to count our ASAM features that intersect with EEZ features. We're not going to worry about search radius in this particular example. And if we open fields here, you're going to see this area where we can select our output field and our merge rule. So we want this to count. And we are going to okay, we're just going to explore this together because this does not quite match what you're seeing on your instructions. So we're going to set our target feature to the EEZ and our join feature to the ASAM. And we're going to leave our match option as intersect, and we're going to use our merge rule count. And we will see what this gives us. This is an important part of troubleshooting when you're doing GIS. If something doesn't quite line up right with what you're expecting, is sometimes you just do it and you evaluate the results you get to decide whether or not it's what you want. Evaluating your results is just something that you should get into the habit to for everything, because it's how you're going to learn, and it's how you're going to be able to know that you have done things right with what you're doing. Speaking of, does not appear that our spatial join has done anything. So let me open our history. Huh. Interesting. So this history tab is a really good place for you to check all the different tools that you've ran in a certain project. It's going to keep everything that you've done. In this case, we see that our spatial join did go off correctly. But we do not have our new layer for our spatial join. So what we're going to do real quick is we're going to come here again, joins and relations. We're going to add a spatial join. Only this time we're going to have our target features be our ASAM, our join features be our EEZ. Still want it to intersect. We want it to count, and we'll let it stay on ID. And now we're going to run this spatial join again. I will see what happens here. What we should be seeing is a new layer created. Oh, that's interesting. This particular tool was not asking me about a layer, which would be why things are being weird. Oh, I see. Okay. So the way that we did our spatial join through here did not create a new layer. It added onto the attribute table of our data. So we'll see here that to description 6 is where this ASAM table used to be. And now it extends out here to our object ID, our join count, target FID, etc., etc. We have our country, sovereign, remarks. So it's joined all of our information in the attribute table. And then it did it again because we ran it twice. So we'll just ignore all of that up to this object, this second object ID, we'll just ignore all of that part of the table. Another way that you can do this spatial join is to come up here to your analysis ribbon and go to your spatial join just available here. This is how you would create a layer. So doing it directly on the contents pane will add to a table. Doing it through your geoprocessing tools, you'll select your target features as our EEZ, our join features as our ASAM. We'll give it an output feature class. I'm going to call this say ASE join. Join one-to-one, intersect, merge rule count. If I run this, we'll let it run one more time. This should give us, because it says output feature class, this should now give us a layer with everything joined up. Technically, both ways should work just fine. But if you did want to create a layer on its own, this would be how you would do that. You can see here that we now have our data. And it's going to have a couple different repeats because we edited this one directly. So it's kind of up to personal preference. For me personally, I like to keep my data as preserved as possible. So if I have to go back and adjust things or start over, it's not as painful. So in the future, I will probably use our geoprocessing tool that creates a new feature class and not do it directly through here. Regardless, you should now be able to answer question 5 to find out which zone has the highest number of piracy points. So that would be this here, the join count. This is going to tell you in each area how many things it counted from our join features. So join feature count. And you can see here that if we select this one, for instance, we zoom to it, we'll see that there are 0 piracy anti-shipping events happening here. Versus if we zoom to this one, we see that there are a few. So if you're a little stuck and interested in figuring out how you would find which zone has the highest piracy count, because there's just so much of these, what you'd want to do is come here to your join count, sort descending. You're going to get your highest number on top. You're going to find that the EEZ zone is your Indonesian exclusive economic zone, has the highest number of incidents. This is not the highest density, which is really what we're after. Because Indonesia might have the highest count, but density takes into account area. I'm just going to keep saying this over and over again. So now we are going to, well, for funsies, let's go ahead and zoom to this zone. No. To this zone here. Here we go. We see that it's a very large zone with a lot of different areas for ships to be based. So it makes sense that there's a lot of action happening here. So now we're going to normalize this data in order to find the highest density of anti-shipping events. And how are we going to do this? Well, we're going to do some field calculations like we did a few exercises ago. And we're going to calculate the area of each of these EEZ zones and then calculate the density of our piracy count to our area. So we're going to come here. We're going to add a field and give it a name. Your instructions encourage you to name it like this: incidents per square mile. You want your data type to be float. Again, this is what's going to allow you to have decimals, and we want decimals. Going to come up here to our top ribbon and save our changes. Whenever I'd like to do that. I'm going to come back here to our table and find our new field here at the end. We're going to clear our selections. We're not dealing with anything. And we're going to want... Oh, sorry, I'm getting ahead of myself. We're going to come back here to fields, and we're going to add another field. This is going to be our density. But first, we need a field for our area. So we're going to call this area miles squared to keep track of our units. We want this data type to also be float. And now we're going to save. Come here to the table. Beautiful. We're going to right click on this and calculate geometry. Once this loads up, we want our input features to be the field, or not the field, the layer. So that's our join layer. We want it to populate this field. We want the property to be area, geodesic. We want our area unit to be square miles somewhere. Now there's a couple different options for us here. We have our square statute miles, our square international nautical miles, and our square US survey miles and US survey nautical miles. I'm going to go ahead and choose international nautical miles, since that seems to fit the theme of this data the best. And we're going to give it the coordinate system. And I'm going to do it the easy way by selecting a layer for it to pull from. We'll do current map. That seems safer. Maybe. No, it doesn't. We'll do this. And then hello. Okay, yeah, that's what we want. Click OK, and now it's going to run. And we're going to give it a little bit of time. Oh, and we have a problem. So we see we have our invalid aerial unit value. So give me just a minute to troubleshoot. Okay, so if our aerial unit is invalid, that likely means that using square international nautical miles was not the correct way to go. So instead, we'll come here and we'll try square US survey miles. We'll try this again. Oh, and we can see that our coordinate system has switched over to a real coordinate system instead of the jumble we have here. So that's a good sign. We're going to try and run this again. And we're going to give it a hot second while it works on this for us. Oh, he's trying so hard. I guess now is a good time to ask everyone how their day's going. Encourage you to to go outside, breathe some fresh air, and do something fun later. It's just a awkward small talk moment. We'll give this a hot minute to run. And we are back, and our area has been calculated for everything. You can look through here, see it's all looking good. I'm going to go ahead and come here to one of our smaller areas. Oh, hold on. I don't have this sorted correctly. Sort ascending. I'll say this one. I'll zoom to this particular option. Where are we? We are over here. I'm entirely sure which country we're by right now. It does look like this little tiny area. Seems reasonable for this to be only 4 square miles. If you come here to this one, which is 100 square miles, say that, yep, that looks reasonable for that to be 100 square miles as well. So now that we're feeling pretty confident that our results came in correctly, we are going to perform our field calculation here in our incidence per square mile density field now. So we're going to calculate field because we are going to take our join count, double click this, over our area, oopsies, down here at the bottom, and click OK. We'll let that calculate that field, which should be a much quicker process. Hopefully. And there we go. Goodness, excuse me. All the yawns today. All right, there we go. That was a little scary. It's just occurred to me I've not been saving, so this is your reminder to save your project. Now we have our incidence per square mile. So again, I'm going to come here to one of these areas up here at the top that has 0 incidence per square mile. Going to find our zone and see that there are, in fact, no incidents in here. Here we have this weird fractional number, which makes sense if there is an incident occurring right here. We do have one incident within this smaller zone, so it makes sense that it's a small number. We're going to sort descending now through here and look at a few of these incidence per square mile densities that are a little bit bigger and see that there are, in fact, multiple incidents in this area here. So yeah, here we have now our incident densities, and you can now use this to determine the answer to question 6, which goes over which 3 countries have the highest number of anti-shipping incidents per square mile when normalized by the area. And you'll list that from highest to lowest in your quiz responses. And just as a quick note, you just need to list the countries, not, Bangladeshi exclusive economic zone. Just put Bangladesh. Or, Omani exclusive economic zone. Just put Omani. Or Oman, sorry. Not Omani. So put this value in. Alrighty, this next task we're going to do is to determine the number of piracy acts that have happened near the U.S. And we're going to define near the U.S. as within 200 nautical miles. So I'm going to zoom out here from wherever we're at to our full map. I'm going to clear my selection and move these tables down so I can see the map more. Now, the first thing we're going to do to find out how many events have happened within 200 miles of the U.S. is we're going to select the US from our countries layer. And there are a few ways to do this. We can either come here to our countries shapefile and find our attribute table and come down here in our name. We could have done this an easier way, but find the US and select from here. You'll see now I have the US selected, or we can come here to map and then click on this selection tool and then just click on it, which will also select the country for us. Keep in mind that tool will select from your topmost layer. So if you had another layer with things happening in this area, and you were to click on a point that shared the location occurred in both layers, then you would have an issue using that tool. So you just want to make sure that you are being very clear to ARC what you're choosing when you use this select tool right here. But either way, now we have ended up with the US selected. And we are going to now come to select by location. We're going to use this panel to define what we want to select. So go ahead and give this a try on your own to see if you can figure out how to set this up in order to get what we want, which is the number of anti-shipping events within 200 nautical miles of the US. Now, what we're going to do here is we're going to have our input features. We are going to pull our features from our ASAM file. We want it to be within a distance. We want our selecting feature. We want within a distance of our country's file. Now see here, it's going to tell you that this input has a selection, which is what we just did. So that means it's only going to process information according to this selection, which is very useful for what we want now. Next, we're going to put in that we want to be 200 nautical miles. And again, we see that there are a couple different options for nautical miles. We're going to click the US survey nautical miles since we are dealing with the US here. And click OK. We should now see that we have 81 selected features, so minus the US country shapefile. That means we can determine that there are 80 features selected in our acts of piracy. Again, if we were to come to this table here, we're going to see that we have 80 of the roughly 8,000 events selected. We can sort by our selected to see that all of these occurred in... Oh, it doesn't look like this table tells us in what area it occurred in. That's okay, because if we zoom out here, we can also see that our selected highlighted anti-shipping events are within the different territories of the US. So that is actually, spoiler alert, the answer to your question 7. And now we can move on to task number 3. We're going to clear our selection here. So this third and final task is to create a buffer and clip in order to isolate and visualize the acts of piracy that have occurred within 100 nautical miles of the Caribbean islands. So the first thing we're going to do is we're going to use the buffer tool to create a buffer around the Caribbean islands, which we know are right here. I'm going to come out here to our geoprocessing and search in our toolbox for the buffer tool. And here we want to select the buffer from the analysis tools. Now we're going to set our input feature. So this is going to be our islands. Our output feature class, I'm going to name this CIACE buffer. We want this to be a linear unit. And since we're searching for 100 nautical miles, again, I'm going to use US survey nautical miles, and I'm going to use 100 in our distance value. This side type right here, we see stop it, is going to specify which side of the input feature that will be buffered. So you can see here that if we were to use full, that our buffers will be generated on both sides of the line, or be generated all around the polygon. It will contain overlapped area of the input features, which is our default. We have our left, so our buffer will be generated on the left of the line or the right of the line, which is not helpful for our polygon features. Or we can exclude the input polygon from the buffer, which would mean that the buffers will be outside of the input area, which is an option, but for our purposes, because of the way our data is occurring on our map, that might lose some of our points, because if we zoom in here, we can see some of them are very close or technically on the shore. So we're going to want to leave that side type at full. We want our method to be planar. We want our dissolve type to be set to dissolve all output features into a single feature, which is going to mean all of the overlapping buffers for the islands are going to get globbed into one smooth shape. So now we are going to run this, and it's going to generate a shape file for us. We'll see in just a second here once the tool finishes doing its thing. Whenever it finishes doing its thing, we'll give it a minute. And now we've got our buffer. So you can see it's kind of this weird little blue blob that covers all the Caribbean islands. I'm going to turn off some of these other layers so we can see it a little bit better, to see how it is extending out 100 nautical miles from all of the islands in this area. Now we're going to use this shapefile, and we're going to clip our anti-shipping events file so that we can visualize just the piracy events that are happening within the buffer instead of getting all these ones outside of our area of interest. So we're going to come back to our toolbox, search for clip in our analysis tools. We're going to clip from the input feature is what we are clipping. So we want this to be our ASAM features. Our clip feature is going to be our buffer zone. So this is going to define the area that we're clipping. Again, if you ever are confused, you can come here to this information bubble. This is a much better example of it telling you that the clip features are the features used to clip the input features, the features to be clipped. And then we're going to name our data set, E. And you may see on your instructions to leave your XY tolerance blank. As you can see, there isn't a parameter called XY tolerance here or in your environments. For the most part, you don't need to worry about your environments. Oh, I lied to you so hard. I meant that the XY tolerance is here in your environments. You don't need to worry about this. Just leave it blank. And for right now, you don't need to worry about environments in any of your exercises. This is something you'll dive more into if you go further with GIS. But for now, this is going to be the tool that we run. Give it a minute. And here we go. Now we have our clip file here, which means we can turn this off and we'll see that everything inside the buffer is staying the same, while everything outside the buffer is disappearing. So now we see that our map looks very similar to the results given in your assignment instructions. And you can now answer question 8, which is how many incidents of aggression. I did not do that very well. That's a little embarrassing. Piracy acts occur within this buffer. And let our dear author of these instructions enjoy their pirate puns in the silence of our own minds. And that's it for this exercise. So now you're ready to prepare a formal map for your submission. Keep in mind what your map's purpose is, which is to display the anti-shipping events occurring within our buffer zone here of 100 nautical miles of the Caribbean islands. You need to include the date of your record. So include the date, your author and data credits, all your metadata, any other map elements that you feel will support your map purpose. And make sure to remove your spatial reference credits and your base map credits. And yeah, now's a great chance to have some fun. You are given permission to have fun and make this map look fancy schmancy, a little piratey themed. You have a couple different options for picking fun looking base maps that kind of look like maps that you can find in the Living Atlas here in your catalog. So if you come here to your catalog, you come here to Portal, you'll find this cloud with a little book on it. This is your Living Atlas. And here you can search for pretty much anything. In particular, the map example given in your instructions was pulled from here in the Living Atlas. So you can search for base map. And it'll give you a ton. So you may want to be a little bit more specific or explore through these. You can also find that through coming up here to your contents pane, view, catalog view, and doing the same thing here, but you can also find it here in your catalog pane. I'm going to close this. And yeah, that's basically it. Good luck, happy mapping, and make sure you submit both the questions to the answer form in Canvas and your final map. Alrighty. I hope you all have a good week and good luck with all of your doings.